All right, this is chapter 7. We're talking about our conics. We're now on parabolas, section 7.2. The things we want to be able to do are to know the four equations for parabolas and recognize the equation when it's not in standard form. We want to be able to put it in standard form and from that tell the direction of opening, the vertex, and the focus. So here's our definition of a parabola. A parabola is the collection of all points P in the plane that are the same distance from a fixed point F as they are from a fixed line D. So here's our fixed point F. Here's our graph of our parabola. And note that the distance from this point P on the parabola is the same distance to the focus as it is to this line labeled D. And that's true for every point on here. It would be the same distance from the focus to the line D. So F stands for the focus, V stands for the vertex of the parabola, and D is the line called the directrix. Note that line here is perpendicular to the line coming from P, and we also have this other piece of information. The distance from the vertex to the focus, remember since they're the constant, vertex to focus would also be this has to be the same distance vertex to directrix, because every point on here is the same distance to the focus as it is to the directrix. And that distance here, the special distance from the vertex to the focus, is called A. So that would be twice A, but from vertex to focus, the distance is always this lower letter A, which we're going to see how that fits into our equation now. So the equations for our parabolas are given here. All right, standard form for the equation of a parabola with vertex HK. So we have four types. First, the ones that open up and down. Recall, these are our functions, right? They pass the vertical line test, the ones that open up and down. So we've kind of talked about them before. We haven't talked about the right and left ones because previously we talked about functions and they would fail the vertical line test, so we weren't looking at those. Okay, so what would the equation be if here's our vertex, it opens up, there's the focus, it's at the point H. Of course, if it's on the same vertical line, the x coordinates are the same. And this is K, so this must be K plus A, because remember that distance. We said the distance from the vertex to the focus is this lowercase letter A. And of course, we always have our axis of symmetry. Here's our directrix here. So what's the equation? It's x minus h squared equals 4 times A times y minus K. Now note, only the x variable has a square on it. Remember that was true for parabolas that opened up and down. X was squared. Those are our quadratics. Y wasn't squared. X was squared. Okay, so the ones that open up and down, x is squared. There's HK. That's our vertex. So the vertex is HK. And that A right there represents that distance A from the focus to the vertex. Okay, what if it opens down? The only thing that changes is what you probably are expecting. X minus h squared equals negative 4a y minus k. So we get this negative that makes it flip over the x-axis. Okay, so the ones that are not functions that we haven't looked at before are the ones where y is squared, not x. So we'd have y minus k squared equals, if it opens to the right, 4a x minus h. Okay, so the y is the variable that's squared now, and but h and k, h is still with the x and k is still with the y, of course. And then this distance here, this is our a from here to here, vertex to focus. And of course, to make it flip to the left, I'm sure you know what happens. It's y minus k squared equals negative 4a x minus h. X minus h, right? Okay, so we need to have this understanding of how this is formatted. Just like we did for the circle, We had to know the standard and the general form. For the parabolas, we need to know these four standard forms, and we need to be able to get an equation in this form if it's not already in this form. So we'll practice some of that in the next video.